I think it's my privilege and honor today to conduct this session with all the stalwarts who make the cement plants work and cement plants go. Over the last few years, the challenge that we have seen, I don't know if my signal is coming because, sure.
It is coming, okay.
Is there? Am I audible?
Yeah, sir, you are audible.
Audible.
1 second, let me just switch off my video. Am I audible now?
Yes, you are better.
Okay, sorry for all this confusion. I'm in a little bad bandwidth area. What I was saying was that over the years, as country India and as world, we have all become very aware of the challenges which we face in terms of carbon emission and in terms of environmental hazards that we are facing. And in the COP26 this year in Glasgow and other places, all countries have taken good targets in terms of reaching net carbon emission kind of net zero emission world. India has taken some targets for 2030 and a target of 2070 to be totally at net zero. Similarly, all the countries in the world have taken their own targets. And I think so we are all well aware of the need of the challenges that we face in terms of making our business sustainable, making this earth sustainable. And to my mind, to solve any situation, any problem, and in this case, we have a burning platform in terms of the environment pollution that we are having. You need to have three things in place. One is that you need to understand that there is a big challenge that you're facing and you need to do something about it. Second is to have the mindset and commitment to do it. And third, and more importantly, is to have the ways and means and via media to make it happen. And that, to my mind, is the technological interventions that are needed to make this kind of a vision a reality. And I am indeed privileged today to have with me Mr. Carlson from FLS Smith, Mr. Justus, Managing Director, IK and GMB, Mr. Ashok Demla from KHD, and Mr. Vivek Bhatia from Thyssen Group. I think I have a fantastic August gathering of experts who will make the cement industry and the world in so many other areas reach the target of net carbon zero or net emission zero and help us in that journey. And without much ado and without taking too much of a time, what I would propose is that I initially would ask and request all the fellow panelists to take 5 minutes and share their views on what do they see are the big challenges and the opportunities that we find in terms of the topic of today and the role of technologies, how technology can help us, what would be the challenges in that, and what are the opportunities. And I would request that if you could stay at around 5 minutes, then what we will do is I will then after that take on maybe a question each with each of the panelists and then open the house for any questions which the people who are attending this conference may have. So I'll start with Mr. Carlson. Over to you and look forward to hearing you.
Thank you very much, and thank you for inviting me to this important conference and session here. I appreciate it very much. Yes, as it's evident for, I believe, everyone in our industry and certainly everyone in our stakeholder group around the world, cement is a major contributor to CO2 emissions in all its aspects, 7 to 8%, as we all know, of the world emissions. So we have a given job on our hands to ensure that that is reduced and ultimately down to a zero emission level for cement production. And I think there is a number of challenges, but also opportunities we have on our hands to change this situation. If we look at the stages towards a zero emission cement production or clinker production, then we talk about the four main elements, right? We talk about the importance of efficiency of our systems, so state-of-the-art equipment. We talk about the importance of fuel substitution, so that we use anything else but fossil fuel. We talk thirdly about clinker substitution, so reducing the amount of clinker we use per ton of concrete. And then, of course, ultimately, the removal of the remaining part of the CO2 from our process. Globally, all four elements are a significant challenge for the industry and for us all. For India as such, I believe on a number of these four elements, you are actually ahead. In terms of installed base and therefore state-of-the-art equipment, India is ahead of most countries in the world because you have a very new installed base. So the CO2 emission per ton of clinker is relatively low. So I think the main, and also for clinker substitution, you're also using a lot more than other parts of the world. So the two main elements here that we should look at is fuel substitution and all that entails, as well as the ultimate solution for the remaining part of the CO2. So those are the two technology-wise challenges. And in terms of the four first ones, as you know, the industry has examples around the world for 100% fuel substitution. We, for one, is able to deliver both the mechanical and firing equipment for it, but also, more importantly, the control systems that is needed with it. So to get to 100% fuel substitution, that is a possibility that doesn't need much new technology development. When it comes to the CO2 removal, also here there is a number of options, both traditional ones, but also newer ones. I think the main challenge here is to find a way to remove CO2 from the flue gas in a less costly way, a more reasonable way for the industry. And I think here we have a number of new technologies being developed, and we are testing too for the moment, where we will have a much lower install cost, capital expenditure, but also, more importantly maybe, much lower operating cost. So those are technologies. I think ultimately the challenge is also for the world to create a demand for green cement. Generally across the world, there are still very few large infrastructure projects being built where there is a requirement to green cement. So we have to, one, define what is green cement. Is it 50% reduction in CO2 emission, or is it 75, 100? And based on that definition, then to create a pull effect for cement that is green. So I've covered where do I see the technology challenges, and I've covered where do I see the market challenges. And I think that's two of the ones that we have to discuss in such a panel here. So with that, thanks.
Yeah.
Thank you very much. Sorry, I was on mute. So you touched upon some very important points, Carson, and I think in India specifically, I would like to, as we move forward in our discussions, focus on how we can reach, 100% looks to be pretty optimistic at this point of time, fuel substitution. But can we, start targeting 50%, 75%? Because our country's average today would be about 5 to 6%. And some of our best plants would be still operating in the region of 20-25%. So there are a number of new things we are all trying. Even in our company, we are doing that. So I think that would be a very interesting topic to discuss as we move along. I would now like to invite Mr. Demla to share his opening thoughts and comments on this topic. Mr. Demla, I would request you to share your comments on this. Sorry, I don't know if you're hearing me.
Sorry. So basically, I think Mr. Lund has given the whole scenario, but within that scenario, you know that so far as clinker factor substitution is there, we are doing very good in that area in India. I mean, right from efforts on the fly ash utilization, slag utilization, and then other forms of blast furnace slag. Now the stress is towards composite cement, where we are planning to use LC3 cement. So that will also give us some relaxation, say 15% LC3 cement. It is approved by IS. If it is approved, then that will be another good factor. Then, of course, limestone in some countries it is used up to 5%. So that will also give another area of improvement in terms of clinker factor substitution. Basically, more we do clinker factor substitution, we are going towards carbon reduction. So, I mean, some studies say that 37% of the carbon dioxide can be reduced by clinker factor substitution. Second important factor is where a fuel substitution is there, where we have efforts up to 12-13%, which we can achieve carbon reduction. So there a lot of efforts are being made in calciner. There is a possibility to reduce the carbon dioxide, say alternate fuel with the fossil fuel. You can replace alternate fuel. Even you can use alternate fuel to the tune of say 85 to 90%, because in calciner the temperatures are less. So technologies are already available from all the suppliers, including KHD. In calciner, we don't have doubt that because of low temperature requirement, this technology will go only tag in India is how to collect the waste and how to utilize it properly. Municipal waste gives a very, very big opportunity, and people are working on RDF and municipal waste. So that area will, I think, develop in coming future for the calciner fuel, apart from agriculture waste and other wastes which are available, pharmaceutical waste or chemical waste and all these. But a lot of efforts are required by all the agencies, including government, to provide this waste in a proper form, even the industry. So that area, I think most of the people know, but the opportunity there is only 12 to 13% reduction in carbon dioxide. So if we see these two opportunities, 50% of carbon dioxide can be reduced. Then out of rest 50% carbon dioxide, there are two avenues which are available to us. 50% out of 50%, 25% can be through new technologies. New technologies, of course, we are talking about oxy-fuel technology. We are talking about some low belite cement. Sometimes we are talking about can we produce say clinker in the form of pure carbon dioxide. I think Heidelberg was trying in one of the plant in Belgium to see that in double chamber, in one chamber the electric heating is there, and in the inner chamber can you have the pure carbon dioxide, so that you can utilize it for easily purpose, and the quantity of carbon dioxide will also reduce substantially. So, but those scales are still on the scale of, you can say, pilot scale. Plants are trying either burning some non-fossil fuel or fossil fuel along with the clinker, say limestone in the pure form. Can we take out the carbon dioxide? The similar technologies are being thought of. The fourth avenue is, of course, the ultimate avenue is CCUS. That means the carbon capture, utilization, and storage. So that also has to be adopted in the long run, in my opinion, because carbon capture and utilization at present, some companies are providing at a very small scale carbon capture, but this has to go in a big, commercial scale. Either it can be used as a, carbon dioxide as a material in the chemical industry, or mainly it has to be put in the geological forms under the earth, and it should remain under the earth. So these avenues, we have time. I think up to 2070, we have committed zero, say carbon dioxide or carbon neutrality, and some countries have committed up to 2050. So I am sure that these new technologies effective way, and the new technologies which will ensure carbon dioxide reduction in the process itself will come up, and there will be good future. But India is doing excellent in say clinker factors of reduction substitution, or clinker factor is getting down and down, and we are also now coping up ourselves for use of alternate fuel. I think with these remarks, I will like to listen to other speakers.
No, thank you very much, Mr. Demla. I think you have brought out some important areas in terms of technological development. And if one can look at it, probably there are two things that get highlighted. One being that, how we can do what we are doing better and how we can reduce the clinker use. But till the time we keep using clinker and till the time we keep producing clinker, we are going to have some form of emissions. And therefore, CCUS is something which we look at going forward as one of the very, very important, ways in which the carbon, net carbon zero can be achieved. And with this, I would now request Mr. Justus von Wedel to please share his thoughts. Over to you, Justus.
Thank you very much. Good afternoon, everybody. ICANN is among the panel members the smallest organization, and we are, I think, privately owned. So we're not pressured by shareholders or any public institutions, so we can follow our own policy, and we observe the market, and we see the challenge coming our way. We are, being the smallest organization, we focus mainly on the capture side and on the efficiency side. So I think one very effective way to reduce CO2 emissions is by being most efficient, and that has been our mantra for decades. And we still see potential to become more efficient and thus more CO2 cognizant. When I look at the capture side, we are involved in several initiatives. We have to bear in mind one overriding concern that I carry with me, and that is the cost on society. Cement is the building block of civilization, and it's our responsibility to provide this binder and glue and platform for society at a reasonable cost. So whatever initiatives that I perceive that are being tossed around mainly in Europe, that's where I come from, it only ends up in substantial higher capex. It adds to complexity in the cement production process. It increases OPEX, and ultimately, which has to be passed on to our customers. And we have to, I see limits to what is possible in passing it on to the consumer. The initiatives that we are involved in, and we're dedicating relatively high degree of intellectual capacity and resources within our organization to focus on these subjects. The initiatives that we participate in are oxy-fuel, calcium looping, and indirect firing. I know there's many other ideas, projects, and concepts being discussed in the industry, and most of them are publicly funded, at least here in Europe, but there are also some private projects with renowned cement producers where we participate in. But all these initiatives or technologies that I see in the direct reduction and capturing of the CO2 in the cement production process will lead to a substantially higher cost. Some of them are not scalable. We are able to reduce CO2 with the knowledge and technologies that are available, but the cost penalty is substantial. So I think this is the area where we have to become better and dedicate more resources to find ways to alleviate the penalty that ultimately will impact on our market and ultimately society. So that is where I see ICANN as a small organization. That's where I see our mission. Thank you.
No, I think thank you, Eustace, and you have actually touched upon a very important point. And it is a different thing to have technology proven or doing a technology demonstration. But on the scale at which cement is used, and particularly in India, where we are the second largest cement producers in the world and also second largest consumers, and growing every year at scales which are pretty high, I think for us the challenge is even more because we need cement for the basic development of the country. There is a lack of basic infrastructure. So it is one thing to reduce CO2 emissions and one thing to reduce your net carbon emissions, but you also need to provide the basic food, shelter, housing for the people. And for that, we need cement. And therefore, each of these operations, if they are not financially viable, are going to be extremely difficult. A typical case in point is that when we look at an AFR, the mindset in our country still is not polluter to pay. And the mindset in our country is still in a way that, okay, if fuel is AFR is being used as fuel, there is a huge, tangible financial gain which the company is making. And therefore, the whole supply chain is not able to work in that manner. And to me, I think this financing part and second part that you said is in terms of scalability, if these two things do not happen, then we are far away. And as I look at it, I think it is going to be extremely important that in the coming years, and in an accelerated manner, we find solution to these two problems in terms of easy financing, in terms of being low on capex and opex, and then in terms of scalability. So thank you very much for your comments. And I would now like to invite, last but not the least, Mr. Vivek Bhatia to share his thoughts and his views on this very important topic. Over to you, Vivek.
Thank you, Mr. Kapoor, and good afternoon, everyone. It was a pleasure listening to all the previous speakers, and I think all the points are very pertinent and very relevant. I just want to take a step back. Now, if we look at cement as a sector, I think we contribute somewhere around 7 to 8% of global carbon dioxide emissions. So whenever any government, any body in the world is going to look at emission reductions or talk about net zero, it is but obvious that there will be a significant focus on the cement sector and what we are going to do to address that. And I think the way everyone has described it is really the way forward, in the sense that we have to first and foremost look at how are our equipment performing, right? And second, we have to look at how we are generating power and how we are consuming power, which ties back to the efficiency part. And then clinker substitution, as Carsten also mentioned and others also mentioned, and subsequently removal of CO2. Now, on each of these areas at ThyssenKrupp, we have a significant focus on moving the needle forward. And we have all of this bundled together in a program that we call Grey Becomes Green. So on efficiency, for example, we are looking very closely at grinding and what is the power consumed in grinding, because we believe that is one of the highly energy intensive parts of cement production. And there with the Polycom, I think we have made significant progress in that direction. Coming to, I think, the generation of electricity, I think we are perhaps one of the few integrated cement plant providers who also provide WHR. So, which is very important, I think, in today's game plan in India to be optimal. So obviously, we don't want a lot of waste heat, but whatever waste heat there is, we want to make sure that is converted into usable power. And today, I think we are at a level where with WHR, it is possible to operate the entire cement island. I'm not talking about the entire cement plant, but the entire cement island, which is, which can be fully run with WHR-based power, which I think firstly is extremely cost-effective compared to a grid cost of somewhere between 8 to 12. Some people are already paying 16. I think WHR is going to cost you one rupee a unit. So I think that's a very important part of the puzzle to use this waste energy. Then I think coming towards AFR, I think that is really one of the biggest untapped potentials in India today. And the problem is not technology. I don't think there is an issue on being able to take AFR into cement plants. Almost everybody we have in terms of the major players, everybody has demonstrated. We have plants in Europe where 100% AFR usage is there. So, so I think technology is right now not the problem. The challenge in India is really the supply chain. And there, I think we need a significant push from the government to be able to bring this waste. Because on the one hand, if you look at Delhi, we have these fires in these dumps of garbage, and on the other hand, we have cement plants who are starving for AFR, which is a huge contradiction. I think it's a lost opportunity. So I think we need to really focus on regulation and government and policy on how to bring that resource into cement plants and make it a win-win from a social perspective and also a cement production perspective. And there again, I think everybody has their solutions. We have one where we have focused very much on, making the auxiliary power requirements to operate the system minimal. So I think then your extraction of energy from AFR then goes significantly higher. I think on the substitution side, India has gone well with fly ash. There has been availability of slag as well. But we are seeing more and more the steel plants are also getting into the business of cement, because obviously then they can get that 50% usage. But I think the big thing which Mr. Dembla also mentioned is also to get into LC3, and there already we are building the first plant in Africa, which is the first plant in the world, I would say, on a new technology which can generate calcined clay at a very, very competitive rate. So with that, I think irrespective of availability of slag or fly ash, you can get to clinker factor, or clinker substitution up to 50%. And that's something everybody should look at very closely, because when you have limestone mining, I'm pretty sure everybody has some kind of overburden. So, you don't have to look here and there for the resource, it's sitting right there in the mine. So with the right kind of assessment, and if it works, then, you don't have to go far to make it happen. The challenge, of course, will be for the GUs, but, various solutions, I'm sure, can be worked out. Then coming lastly, I think to oxyfuels, that's something which we are exploring, not just from a cement point of view, but also we are a large cement player, steel player. So we are also looking at that on the steel side. And I think the idea is very simple, that we get a very highly concentrated stream of CO2. And then what we are doing at Cementech is, with our electrolysis technology, we are, creating green hydrogen. And when you combine a concentrated carbon stream with a hydrogen stream, that allows us to get into a chemicals play. So I think the future will see more and more of that happening as well for cement players. And so then we have to think in a slightly integrated way that, what is the portfolio of products, and there will be products beyond cement that we have to think about and market. And it's not necessary that the carbon and hydrogen combination happens with the cement player. You could be selling or providing concentrated carbon dioxide to other players who would then do it for you. So I think that's the overall scheme of things that I see will gain traction in the days ahead. And lastly, maybe I think we also have to look at it from a building that is being created. And, if, let's say, a bag of cement goes 2x in price because it is green cement, ultimately, what is the impact it's going to have in the cost of a building? And there, I think already some studies show that even if you're doubling, the impact is not that severe, because we are talking about concrete. There are a lot of other things that go into concrete. So cement is not necessarily going to create cost inflation for the end user. And once we have that realization and understanding, then I think many people, including government, will mentally accept that it's okay to pay significantly higher for green cement to have a substantial reduction in CO2, and commercially, the trade-off for real estate might not be that severe. So I think these are things and ideas and concepts which all of us as a industry have to promote to push for greater acceptance for green cement, and then I think definitely that 7 or 8% can be brought down significantly in the days ahead. So with that, let me hand it back to you, Mr.
Thank you very much, Vivek. Thank you very much. Some very insightful points, and I do agree that some things like LC3 and all can become one of the ways in which clinker substitution can be reduced. Only thing that I keep wondering, and when I look at, is the availability of clay which can be calcined, and that is the place where what Mr. Lund was saying some time back, the scalability of LC3. There is a concept proving, and then there is the scalability of availability of clay, which whether because we did try some trials on clay availability, but not get some very good results overall. There. Am I audible? I see you going down.
Yes, you are.
Yeah. Okay. Yeah. Sorry. So to be basically, after hearing all four of you, I think getting very good views from you, I would rather try to put the entire challenge in terms of technology in 3 parts. And the first lever that I would say is the traditional lever on doing what we are doing better than what we can do, or try to get the best practices across the globe in all aspects of cement manufacturing. And this could be in terms of energy efficiency, it could be in terms of clinker substitution, it could be in terms of alternate fuels and raw materials. For example, in energy efficiency and clinker substitution, we in India are doing fairly well. In AFR, as has been highlighted, we have a lot of gap to cover. Whether it is supply chain or whatever, the net result is that we are not able to use it. And therefore, as a nation, as an industry, we need to put our act together on that. The second point would be, innovation, looking at new technologies. You spoke of oxy-fuel, we spoke of CCUS, it could be green hydrogen, it could be electrification of kilns, and, complete alternate building materials, which we can talk of concrete or talk of using, all kinds of materials that can help us in making alternate building materials which have less carbon emissions. And to combine all this, I would say that another lever which is very important to make all this happen, and support system which is needed, is that the industry needs to move very, very clearly towards a digital journey. I would say Industry 4.0 is no longer kind of an to-do and not an option in terms of process digitization, in terms of advanced analytics, automation and robotics, digital asset optimization and reliability. All these are the areas to work. I was actually intrigued, Vivek, when you made a mention of, cement. I was just wondering, what would be your observation when you are, working in different industries, and how would you say the industry is tackling this challenge as compared to vis-a-vis, let's say, a steel industry or some of the other industries? And this question is open to other panelists also, if you have any view, because we would really like to know that as cement industry, are we doing enough? Are we behind? Or we are in a good space?
So I think we need to de-average that a bit. If I look at the industry in India and the players in India in cement, I think there are clearly 3 groups. One is really a progressive group, which is focused on best-in-class, best available technology, and trying to be state-of-the-art. And then there is a group which is in wait-and-watch mode. So they're just looking at what's happening and want to be maybe followers. And there is a third group which is simply does not care. And on the average, I think we are. If I look at the industry as a whole, I think we are more on the progressive side than on the we do not care kind of perspective. So which is good news. And definitely, if we look at the large players, everybody is thinking about lab automation. And wherever we have supplied lab automation solutions, I think it's been very impressive, because it's one way to say that once a month we will look at average performance, but it's another thing to say that we are optimizing across, at a much shorter cycle time, 3 hours, 4 hours, whatever, or some customers are even now asking us for real time. So I think that is a very positive thing for the industry, that we have a lot of people who are really progressive in their thinking. And I think from the government side, with the PAT efforts, so PAT has really brought that consciousness for even some of the players who might have been reluctant, but now there is that consciousness with PAT to think about doing something. Where I think more could happen is, as you very rightly mentioned, I think on the IoT side, I think barring some of the larger players, this is still something that we have to wake up to as a potential. Although I think whenever I've had that conversation, there's tremendous interest around it. But in terms of doing things on the ground, I think we've lagged behind. And then lastly, I would say, we have not really gone out as an industry, and I'm not talking about the equipment suppliers, but I'm now talking more about cement producers. The cement producers have not really, worked with the government more aggressively on the streamlining for AFR. And, there's been a lot of talk that we can put in the AFR, but we have not really engaged in a structured way, pan-India level, central government, state government levels, to, have a consistent policy in India for waste. And that's where I think lies the biggest potential, and it's a low-hanging fruit, because if we get the policy support for that, if there are clear guidelines on how municipal waste in India will get managed and streamlined, then I think that could unleash a wave of improvement for the industry. And so I struggle to understand, and maybe Mr. Kapoor, you can shed some light on where you've been struggling and what we could do together as an industry to, push for a more supportive policy ecosystem, which allows AFR to go up to 50% plus. There's no reason why India shouldn't be at that level, especially with Swachh Bharat. I think the government also wants to do it, but we are not seeing that traction on the ground.
Mr. Kapoor, if I may come with a viewpoint of looking at mining minerals and cement, as you know, FLSmidth is heavily into both. And then from that perspective, I think also cement is, in global terms, moving ahead very fast, and then have very clear ambitions and very strong ambitions. I met some of you at COP26 in Glasgow, and then the cement industry globally was very well presented and had very clear messages. In my opinion, we have over the last couple of years seen a huge move from somewhat passive maybe to really wanting to make a difference. So that is one. I also believe in relative to your point number 3 regarding sort of digitalization in its broader sense. It is for years we all of us, right, have been working with digitalized solution across the complete system of a cement factory, from the mine to clinker or even packing. This is not new for us, and we know about it, and some of us are heavily into it and using very modern artificial intelligence algorithms to become better here. If you look at other industries, that is nowhere nearly as pronounced. Mining for sure not, because they see it much more in silos. So I think we can be happy with that. Maybe my last point, while I have a chance here, I would like to, if we look across the 3 elements you mentioned, it's for me extremely important to remember that an industry that emits so much as we do, any improvement is very, very significant. So it's more important to do, in my opinion, more important to do 10, 20% now or tomorrow than waiting for an ultimate solution of carbon capture at the right price level in 5, 10 years down the road. So I think we should be proud of what we've done so far, and then we have to push on with incremental improvements all the time, because that really helps the environment today. I think that's very, very important.
Thank you. That's it makes a lot of sense, and it gives us a bit of a feeling of pride that as cement industry overall, even at a GCCA, we have taken some voluntary targets in terms of carbon emission reduction. And so therefore, I think the cement industry seems to be in a good space. But going forward, I think if you look at India, one of the biggest challenges that we have in our country, which we have discussed, and Mr. Devla also spoke about that some time back, is in terms of also the AFR utilization. And my question to Mr. Demla would be that is it possible that in India we can start looking at 100% AFR utilization? And as Carson was just saying, okay, let's not talk of 100. Let's first look at 50%. Is 50% doable in India? What is it that we need to do? And I can just tell you that recently we have started, some of the cement plants in India have started putting a chlorine bypass system. And the dust that is coming out is creating a huge amount of problem for us. What do we do with that? How do we use that? Is that recyclable, or what is going to happen? Because the percentage of dust that comes out of chlorine bypass is a challenge which we are facing, and we are in the process of just installing one chlorine bypass system from among one of the equipment suppliers who are there in this forum today. So, Mr. Devla, your views, is 50%, 75% possible? And if so, what do we need to do as industry? Yeah, over to you, please.
In case of, say, consigner, as and collecting agencies and how they collaborate themselves, and cement plant also doesn't get this whole burden on itself on the plant. So there a lot of agencies have to come together, and government has to definitely support. You remember the case of Goa, when Goa government decided to make the alternate fuel or municipal waste as a very usable product. So everybody was ready to take it in that area, ACC, Wadi, and nearby plant, JK Mudapur and all. So it was very useful. So similar models can be extended to other cities also. But on the parallel side, cement industry is also doing a lot of efforts to put their own, municipal use of municipal waste. So that will solve the problem. I think in calciner fuel, the only problem will remain from process side. If chlorine is very high, then you require this chlorine bypass. So we have to find methods how to use dust. If the chlorine is going exceedingly high, then how to use this dust for the simple filling purpose in the mining area or somewhere. If the chlorine is not that much enough, still we can use in the final product up to some percentage. So this is under debate at present. So how to reduce the chlorine in the alternate fuel, that will be another area. I mean, we need not always use high chlorine material. And can we sort out during the RDF formation of material, chlorine is less or so. But at present, I am seeing the trend that there are many plants where chlorine is exceeding in the bypass as they increase from 35% or more. And then this problem of bypass is coming, which is also waste of energy up to some extent, and use of this dust, how to use it effectively. This is a very hot dust, and you have to cool it down and then use it. I mean, where to use it, whether only for mine filling or alternate raw material, alternate concrete materials can it be used, or some other methods. So this is one open area. Then coming to kiln side, how to use maximum alternate fuels, that is a big challenge. In kiln, you require very high quality raw materials, like fossil fuel fortunately has high quality, so you can maintain temperature of 1500, 1600 temperature. Now plastic waste can be used, or the materials which have high calorific value. So those can be used. They are from chemical industry or pharmaceutical industry, they can be used. Then we are talking about oxy-fuel. Oxy-fuel, I think Mr. Bhatia has also pointed out. Oxy-fuel will also be important in the kiln firing. Then apart from this, whether we can talk about green hydrogen and all, we have to find a good method of high quality fuel in the kiln. So if we can replace at least 50% or 60% of the kiln firing, normally you all know that 40% of the fuel goes in the kiln and 60% goes into the calciner. So calciner problem is a little easy, but kiln side, if you can replace 50% in the coming 10 years or so by oxy-fuel technology or through plastic waste or chemical waste or pharmaceutical waste, and without emission problem, perhaps 20% there and 80-90% here. So 60-90 means almost 55% you are substituting fossil fuel in the calciner and 20% here, so you can achieve 75% fuel replacement. So that is one part of the alternate fuel. On the efficiency side, yeah, Mr. Lund has pointed out very excellently that what we are doing is very, very important, incremental increase in technology. Mr. Bhatia has also pointed out low power consumption in, say, raw material grinding, in cement grinding. We have technologies, roller press or vertical mill, whatever technologies we have. We should use the minimum energy. Then we are also improving our calciner technology, and we are improving on, say, cooler technology. I think ICANN is doing excellent work on HAR and mid-roll crusher, and we are also doing the similar way. So these all small steps are also very, very important from angle of, overall reduction in thermal energy consumption or the overall electrical energy consumption. You will be, latest plant of WHR. Of course, government must put more efforts on installation of WHR everywhere, and the industry also has to spend capital capex on these plants. But can you imagine that now almost 85 to 90% of the electrical energy can be generated through WHR in up to pyro. So up to pyro, if your energy consumption is 40-42 kilowatt hour per ton, and if you are producing 85% of that through WHR, you can imagine what is the carbon dioxide you are releasing. So that portion will be very, very important. I mean, WHR government has to support maybe partially, but WHR more of enforcement has to come in, for example, in China or in Japan or in some countries, it is almost compulsory that you cannot set up a plant without WHR. But what about old plants? Old plants also we have to put up WHR. We cannot waste energy now, whatever is available. So these are also steps. Of course, long run, I have already talked about CCUS and all new technologies, which will take its own time or its own way. So, but we should not stop ourselves in between on energy efficiency, alternate fuel, low clinker factor. These are going to be there for coming 8 to 10 years very aggressively.
Well, thank you very much, Mr. Demla. I would now like to actually just, ask a question to Justus on something which intrigues me, and I wonder, are we looking at, somewhere looking at days when the recuperation heat of cooler can get greater than 80% in compound model with WHRS. So we can maximize the output of WHRS, and can we recuperate over 80% of the heat? Is that something which we can do in efficiency?
Thank you, Mr. Kapoor. Very interesting question. Of course, we try to return as much heat from the cooler as possible, and the more heat the kiln consumes, the more percentage will come from the cooler. So we can do 100% if in that respect. So, but we don't want, what we want is the lowest specific fuel consumption of the kiln, and that is then 80% is, with the current platform, is going to be a challenge for a modern operated cement plant like for example such as yours. I would like to come back to what you said earlier, and looking at the time, you said 3 building blocks: best practices, innovation, and supporting system. So we will not reach net zero with the measures that we are discussing here predominantly. I think efficiency is important, clinker factor is important, alternative fuel is important. From my perspective, sitting here in this little town in Germany and looking what the regulators are coming up with in Brussels and Berlin, which is the governing authority for me here, it is going to be a trick. The net zero is something that it's going to cost a whole lot, and I don't see how we will get there with what technology, with which platform to that scale. From a or equipment manufacturer point of view, I need to have at least a vision of developing or a chance of developing a business model. The cement producer side makes long-term commitments, building the land, getting the permits, huge investment, 50 years, 60, 70 years of life cycle. It's going to be under those circumstances that I see coming and on the horizon, building on the horizon. From my perspective right now, I don't know which avenue we are going to take, and that scares me a little bit. Oxyfuel or calcium looping, I think those are the ones that I think we can bring to scale, maybe a combination. We have to look at the existing cement production capacity that is out there. How do you want to we don't want to switch them off. We will continue to operate these plants, and we need to have complementary technology to at least take a turn into the direction of net zero. But I don't see us being, as a cement industry, being net zero in my generation. I don't see that. I'm 54. I'm pretty sure I will not see a net zero. Maybe CO2 is not a product yet. Waste is a product in Europe, so that's good. That helps. So there's a business model, but CO2 is not a product. It has no price. It's a burden, and that's going to make it very difficult for guys like me to turn this into a profitable operation. And I don't look for government support. The government is very flaky. They're herd animals, and it's going to be very difficult to rely on the regulator in that perspective. So I think market forces need to come to the fore. Otherwise, I don't see us as a cement industry be net zero and realize the visions that are perpetrated in Glasgow or in Paris or wherever you want to name it. Thank you.
You have actually made us all think. So in terms of, is cement industry going to reach net zero? Yes, it's a question that whether it's how fast is going to happen. To my mind, we have no choice, and when there is no choice, solutions will come, and that is what I think builds up hope. And like, when you look at a country like ours, India, even if we can make a journey to 80% thermal substitution of AFR, we would have achieved a good goal. Even if, in terms of renewable energy, where we have solar, huge amount of sun in our country, if we can use that storage properly and use the solar part, so we can solve parts of the problem, but the CO2 problem will still stay. And I would like to just ask Carson if he has got anything to, share with us on the various projects which are going on CCUS. Are they looking at reality in next couple of years' time, 5 years' time? When will they be scalable, and when will they be, such that we can plug into our model? And then what do we do with the carbon that is captured? As just now was being highlighted, I use this, that it's ultimately not it's not a product.
Yeah.
It was to me, I believe, right, Mr. Kapoor, and thank you for giving me that challenge just after we heard what could. Justus just said that this is not an easy thing, that this may take a long time. I think we all know that if we wanted to build a net zero plant now, we could do it. It will just be very expensive. CapEx will be hugely expensive, and operating cost even worse, and it will require very complicated operations on a cement plant, which is typically not that complicated to operate. So what we are looking at, and several of us are looking at the carbon capture technologies linked to the process optimization through oxyfuels, etc., that can be much lower in install cost and operating cost, especially more simple to operate. So those three things are the avenues that we are taking, and those two technologies that we are looking at are promising. And what I'm more concerned with the efficiency of the technology rather than whether they work or not. So this is about, I think what we try to get out there as quickly as we can is something that will work, but we need to prove the efficiency of it. And you may know that we signed an agreement with one of the big suppliers in India, which is a part of this getting technologies out quicker. I think what will define whether it will be in our lifetime or not, if I refer back, is how quickly can we get the industry to use this without full commercial backing. If we have to wait until a company like FLSmidth can do this fully commercial with the normal accuracy as you expect from us, then we will need another at least 2 rounds of piloting, each at least 2 years, right? So before we are ready, it's 4 to 5 years, and then you have to build and so on. We're 10 years down the line. So what we're trying to do now is find the technologies, proof of concept, and then we need to get them out and working in your plants. So ultimately, I will reach out, or we will, I'm sure some of my colleagues here also will reach out to you and ask for help in getting this out quicker than we normally would do with technology. Because for the greater good of the environment, we need to do this quickly as an industry. So overall, I'm pretty excited about what we have, and we will have something that will work, but we need to prove the efficiency of it. And then probably it will be my last word here. I'd like to rephrase that I believe strongly in small steps now is more important than big steps in 10 years. What we need now is a change. We need to break the curve. If we can do 5% instead of 7 in 2 years, or any number that we will have done fantastically compared to many other industries. That should be the focus while we are, as you rightly said, Mr. Demblad, we need to make sure that we have this solution for the future. But we need to do both, in my opinion. And I think India is doing very well in showing the world what can be done in terms of limiting the number of kilos per CO2 per ton of clinker. And we should continue doing that. Thank you very much.
So thank you, Kasan. I think you nicely put it that small steps for the big leap that we want as a mankind. I think we need to take those small steps. And I was just pondering when you were speaking that I think time for industry, cement industry, and the equipment manufacturers to join hands together worldwide in various areas, look at the project and take it on, because we can't keep developing the final finished product and then say, okay, this is how it is going to be used. It's going to be developed as we move along. So we need to put it to use. Last, I would just like to, get back to Vivek. I think we have very less time, but Vivek, I just want you to touch upon one very important topic again, the one which I said binds everything, the digitization. What do you see the future for cement industry? Where do you see us going? What happens to the old plants? How can they come into this, jump into this bandwagon and get into a digital journey? Because with all these complexities getting added, nowhere is the need, of a real-time information and real-time solutions more important. Like when we start putting AFR into our kiln, we know that if you can get a real-time information on the chemical composition of what is going in, then you can start managing your process. So over to you, Vivek. I think that would be the last one. A quick comment on what do you see on digitization?
Yeah, no, I see a big wave on digitalization. If I were to summarize it, I think this is going to get bigger and bigger and bigger. And especially, I think, because it's one of the fastest thing you can do in an existing plant. And, any major retrofit takes time, takes capital, but in contrast, putting digitalization into the equation, firstly, to understand, right, where is the energy consumption coming from? And second, then intelligently optimizing your operations, to address that. And I personally believe that, not just from a technology perspective, but when we look at, the ESG statements that all listed entities will have to do, and many cement players, most cement players are listed in India, or at least the major ones are, then I think it will be digitalization will play a key role in helping you understand where are you consuming the energy. And that level of insight is today missing. Once you have that insight, I think, and what I mean is a precise insight of where are the, there is a rated consumption and what is the actual consumption, then I think with that knowledge itself, you could take the first steps to really run an optimal plant. And the ROI on that is also extremely good. because obviously you make sure that you have a streamlined operation, then your yields, throughput, your specific fuel consumption, all of that goes down. So that also adds to margin. So it's a win-win from that point of view. So I think to give you a quick answer, there's a big wave on digitalization, and I think the other aspect which is supporting it is cost of sensors is going down. There is huge amount of talent available. In fact, at TKII, we are hosting the Global Center for Digitalization for the entire globe. So we are innovating not just for cement, but for a variety of other industries. So, and I think the demand is so high, we are falling short of capacity to address the questions our customers are asking. So, a lot of action.
Thank you. I do agree. There is a lot of scope in this. This is the easiest quick win that we have got in making sure that all the technologies that we spoke of can be utilized. We have, I think, come to the end of our time. So I would like to thank Carson, Justus, Mr. Demla, and Vivek for your time. It was a very enriching session for me. I really enjoyed. Look forward to working with all of you, because we are working with all of you in some part or other in our journey towards that carbon zero. Thank you.
Thank you, Mr. Kapoor.
Thank you, Chairman. Thank you, all the panelists. Thank you very much. Thank you.